welcome, and we're very excited to have you all here, and especially on this Circular Thursday. So we're here, and we're waiting for one more member here. So we're here on Circular Thursday, and so we're talking about circularity. I'm sure it's a topic that all of you are quite familiar with, and I'm guessing you probably could imagine circularity something of a rainbow. Why? Because like a rainbow, it's a beautiful topic. It's off in the distance. We all want it. We want to make it happen. But somehow, trying to achieve circularity is very difficult. Just like trying to get that pot of gold at the bottom of the rainbow. So how can we actually turn circularity from this elusive, beautiful idea into a reality? Well, and especially when it comes to end-of-life vehicles, this is an even bigger challenge. Why? Because the average vehicle contains dozens of different types of polymers spread across thousands of components, from very tiny parts to big parts like bumpers, headlamps, seats, carpets, dashboards. And how do we pull out all these parts, recycle them, and put them back into use in other materials, and specifically in a closed-loop system in other vehicles? Well, this was precisely the challenge that we like to solve at the Global Impact Coalition. So I realized I didn't introduce myself. I'm Amanda Martin from the Global Impact Coalition. And at the Global Impact Coalition, we bring together some of the world's leading chemical companies to work on solving these tough challenges to drive circularity and advance toward a net zero strategy in the chemical and plastic sector. And so this pilot really was born out of the challenge of how do we capture and reuse and recycle more plastic parts from vehicles. Today, there's less than 20% of that plastic is recycled in the EU alone, and in the rest of the world, the rates are even lower. And new vehicles have less than 2.5% of recycled content in the plastic parts. So we have a long way to go to increase circularity in vehicles. So what did we do about it? Well, about a year ago, we brought together these different companies, and oops, where's the clicker? I will just show. Aha.
Does it work?
Aha, okay. So here we go. About a year ago, we brought together these 8 companies here. As you can see, BASF, Covestro, LG Chem, LYB, Mitsubishi Chemical Group, SABIC, Suez, and Syensqo. And these leaders from these 8 companies came together to try to tackle precisely this problem. So how did we do it? Or how are we doing it? It's still ongoing, not solved yet, but we're getting closer. So we really brought together these companies in a pilot project where we have dismantled plastics from 100 end-of-life vehicles. And we have redesigned the way that those vehicles are dismantled so that we could separate and sort more pure plastic fractions into different types of polymer groupings. And these were then recycled, were then shredded and sorted, and are now undergoing recycling tests. So we are still, as you can see from the timeline here, in the process of the pilot. It's not over yet, and we are looking to how do we take this forward in a phase 2 next year. But so far, it's been a very interesting learning, and I'm excited to have this panel here to discuss and share more about that with you. Oops, one too many. So, to introduce my fellow panelists here, give a warm welcome to Matthias Scheibitz from BASF Performance Materials, Erik Licht from LyondellBasell, Peter Schwarz from Covestro Engineering Plastics, and John Mortell from Plastics Europe. So, to begin, we'll have a discussion here. Thank you all for coming. And just to set the scene here, we're talking about circularity, but as we all know, regulations are one of the key drivers and maybe prohibitors of some advancement in the circularity. So, John, from the Plastics Europe vantage point, how do you see the role of plastics recycling in the automotive sector evolving under the new ELV Directive?
Thank you. So there's a lot going on at the moment, and right now we're very much in the middle of the end of the legislative process. In fact, next week we have a major meeting with the European Parliament, Commission and Member States to discuss exactly where we are on the end-of-life vehicles regulation and the discussions. What we've had with the European Commission is a proposal for a 25% target by 2032 if the legislation is finished this year, 6 years from now basically, or 6 years from the agreement. We see that the European Parliament, the European Member States, a little bit less ambitious. But what we also see is that these recycled content targets are needed in legislation often to help drive them. And so we very much see this as a very important driver as Plastics Europe. We talk a lot about how to get to net zero, how to get to a circular plastic system, and these legislative targets are very important there. What we do see, though, is that hopefully by the end of this year, we will actually have very definitively exact targets and exact times. So that's maybe a 20% target by 2032, a 25% target by 2036, and with different materials, which materials are included, pre-consumer, how much, bio-based materials, also what the closed loop will be. So I think that's a very important part on this. The European Commission proposal is for 25% coming from closed loops, so coming from existing vehicles. So how much of that will be finalized in the legislation, and how much of this is important in terms of being seen as what is possible? I think often one of the biggest risks in some ways, or one of the biggest negatives on this, is often that different parts of the industry can be much further ahead than a lot of their partners believe them to be. So I think this is where these types of projects have a very big role to play in showing what is possible.
Thanks, and certainly having more certitude around what those targets are instead of kind of being in the limbo of something getting decided will really help, I think. And when we talk about enabling the enabling environment, another one that really comes up a lot is precisely collaboration. Erik, can you tell us a little bit about how working on this project in a collaborative environment is really working, and what are some of the maybe challenges or the areas that you think that can be further explored?
First of all, thank you. And we like to be competitors in the first instance because we have to move and we have to do good things for the industry. But when you think about really the task that we have, Green Deal, Circularity, so we are living really in the most difficult decade potentially, where we have to do a lot of things. And here in that respect, you need stock partners and you need to work together in a pre-competitive way. Because we don't have, at least in the moment, a feedstock problem, so we have a technology problem. I don't know if someone has been on a really post-shredder section to see what comes out. You only can use it for incineration. So therefore, we came together really, and these are not only European-based companies, so up to South Korea, so really a global impact coalition to join forces. Because we are working together to make things happen, really, to go from the fossil-based into circularity. This is the future, this we have to do, and you cannot do it alone. And therefore, it's really intense. So we meet, Amanda, I would say, every 2 months in sprint sessions, weekly meetings, and we do also practical things. It's good to have concepts, but you have to learn, you have to fail, you have to understand. And therefore, you only can do it together. And it's fantastic to have these nice colleagues and the support really from BCG and also from the Global Impact Coalition to have all the experts really in the entire value chain, really from the waste collectors up to the OEMs, and we need the entire value chain, and we have to work together because we need to have really a working process over the whole chain. 90% is not enough. Therefore, I think this is a good start and also a good coalition to make things happen.
Great, and certainly we're happy to have you and all the colleagues on board from all the different companies. And as you have seen probably in the slide I showed before, we have been getting our hands dirty, putting on the yellow vests and getting into this. So let's talk a little bit about what are some of the things that we've learned in this pilot from the dismantling and recovery. Matthias, can you share a little bit about, from a materials perspective, what has the pilot shown around which ones are easier to recover and which types of polymers have been more challenging?
Yeah, I'm more than happy to take this question. Thank you, Amanda. We are very happy to share some of the results, initial results we obtained in this nice consortium Erik mentioned before. We clustered it to a certain extent on, you can imagine, a matrix on where we looked how easy are the parts can be dismantled and how easily are they processed. Process means at the end sorting and for additional processing. And then you end up, let's say, in 4 very rough categories. There are the ones some of you are probably familiar with that are easy to dismantle and also then easy to shred and sort, which are, for example, the bumpers. Yeah, it's very well known. Some of them are getting already mechanically recycled. And there are other parts who are similarly easy, in an easy manner, dismantled. However, there are parts that are a little bit more difficult to dismantle, however, can be easily sorted. Yeah? One example would be the headlamps. Yeah? It's a rather complex part. What the challenge was, as you said, we did a very rough approach, let's say, on the scrapyard, and there's brute force working on this Scorpion. So it's the device we are using for the dismantling, and you can imagine then some of the parts break, so they are difficult to dismantle. However, they are easy then afterwards to shred and to sort. Yeah. So, and then in the other dimension, you have products where it's much easier to dismantle, for example, but they are very difficult to process afterwards. And these are, for example, the carpets. We were really surprised how easy they can be taken out of the car. However, they are extremely difficult to process afterwards. So, and then, unfortunately, also from a little bit from the BASF perspective, there are parts that are neither easy to dismantle nor easy to process. Yeah? And these were, for example, all the parts very closely associated with the engine, be it the cylinder head cover, for example, the air intake manifolds that are all mounted to the engine, which resulted in the way we did it. So we took out the whole engine and then shredded the whole engine, and then you can imagine it's extremely difficult. Yeah, so there are established technologies on that for the people who are doing the metal recycling, but it was extremely difficult, as you can imagine, then separate the parts from the metal fraction. Yeah, so in this way you can sort almost each and every component or module, let's call it, we took out of that, and overall, as a result, we were able to classify, let's say, 80% of the whole parts, of the whole materials were either easy to extract or easy to process afterwards. Yeah? And just as an outlook, and that's what we are now looking more in the details now, we are going to sort them, and after sorting now, feed it into the different recycling technologies that were proprietarily developed by the different companies who are sitting here on stage.
Thanks for sharing. Certainly, it's been a lot of learnings from this pilot, which is why you do a pilot in the first place, so that's wonderful. And we're excited to be able to share some of those. So, Peter, can you tell me a little bit about, when we talk about some of the parts that are easier, but also some of the challenges, can you dive into that a little bit and tell me a little bit about maybe what kinds of technologies or innovations might be most promising going forward?
Well, the point is, everything that is monomaterial that falls apart during shredding is relatively easy to sort, and then with that you can create mono-like fractions that can go into recycling. But we need to face it. Modern cars have lots of multi-material components in there, and they will stay having these in there because the end customer will not vain all the nice gadgets and functions modern cars have. So the end-of-life value chain has somehow to deal with those. Yeah, you can make it easy and say, well, it's up to the chemical companies, develop your processes in a way that it can handle these multi-materials, and of course that's one of the tasks we as the chemical companies have to solve. Yeah, but there are limitations. And again, it's a collaboration thing. So we have to know about our processes. we have to then tell the OEMs or the designers, okay, if you combine these materials, then it can be easily, or it's easier to recycle it. If you combine other materials, it will spoil our process. So again, here we have to deal with that. We have to deal with multi-materials, but there's a lot of room for improvement to find the right combinations, and of course, wherever possible, try to go monomaterial.
Certainly, this is a challenge, not just for everyone in the value chain, really, right? So all the way from the chemical companies to plastics, parts manufacturers to the OEMs. And specifically, then let's take a look back at the regulatory momentum and discuss a little bit around how could these incoming, pending, we're waiting again, still longer, ELV regulations actually help to facilitate this transition. Can you tell us a little bit more about where we're at with that?
There's a few different elements, but I think the main ones right now is what we've seen in, let's say, the plastics value chain over the last few years has been a greater push towards circularity. So we've had the packaging waste regulation, we've the implementation there. We have the development of chemical recycling, which is often very important when you talk about how to meet these more difficult to recycle technologies, the investments that we need there. What we see right now, I think, in many cases, is the lack of certainty really causing a lot of concern, preventing the investment in many cases, or stalling the investment maybe in many cases. We also see that much of the recycling industry in Europe is under a lot of pressure as well because of the prices for virgin materials. And so when you're especially talking about having an infrastructure in place, having clear legislative targets as quickly as possible, and I do have to emphasize, I think we do very much hope that in 3 months' time, 4 months' time, myself or somebody else from that European side of the discussion will be able to clearly say, this is the first target, these are the materials, and now we go. But I do think that we're very much at the end of some of that process, but also the beginning of a lot of the secondary part. And especially when you look at different areas, and it's not a criticism per se, but something that's always struck me is that different people see different parts of it at different points. So the obvious example has been in some cases talking to OEMs who are very reliant, let's say, on packaging for their current recycled content targets, and sometimes having to have those conversations that say, you do realize there's a recycled content target for packaging that's coming on the books quicker. And how do you then ensure that people's mindset changes towards how do we recover much more of that material from the automotive value chain itself, where you know a lot more about it?
Yeah, and certainly there's an interesting learnings there from crossing the different sectors and how can we overall increase the recycled material available. So Peter, can you tell us a little bit about how do you think industry and regulators can actually work together to advance?
Yeah, it has been said at the very beginning, and actually it's really the case. So the regulatory development very much determines in which direction circularity will go. It has been seen once the ELV draft was out, everybody, okay, now we have a kind of direction. And it's not about the number, it's not about whether it's 20 or 25 or whatever percentage, it's about the logic. Logic, you need to have recycling content, you need to have closed loop content. And that's also something from our pilot project. We really need to understand the whole story. We really need to understand what is possible, what is impossible. And so we have to learn along the value chain, but also across the value chain. We have to cooperate. Regulatory should set targets, or probably also ambitious targets, because only setting ambitious targets will really drive development and drive innovation. But we really have to cooperate, to work together, to exchange, and also probably not always hide behind IP barriers. in order to really learn about what is best in that whole value chain. And that's, I guess, where regulatory and industry can very well cooperate.
Thank you. Thanks for sharing that. And let's see if this can become a reality. We can make that rainbow a little bit more concrete and achievable, right? So let's move into, speaking of how do we make this achievable, the elephant in the room always, commercial viability. So how can, we do know that cost remains a key hurdle for circular plastics and plastics extraction from ELVs. Based on what you've seen in the pilots, Matthias, what do you see as potential pilots for making ELV plastics more viable?
Yeah, again, a very good question. And just as a spoiler alarm, so I won't tell any numbers yet, so we are not that advanced yet. However, as Amanda mentioned and the others as well, we learned quite a lot in this pilot project. And from there, you can derive, let's say, I would say a few recommendations or directions we also as a team maybe want to work on in the future and recommend others to work on. And the first one, of course, that will help, let's say, to make the whole thing more viable is, and I explain it sometimes in this way, someone has to pump money into the system to make it work. And what is behind? It's extended producer responsibility schemes. They are quite well known in Europe for fridges, for example. So each and every producer who brings a product to the market needs to pay to a third party money, which organizes then that the material that the product returns. And that is something that needs to be entrusted. In a perfect world, it would be modulated. So there need to be incentives. The more recycled content you have, less you have to pay, for example. So that is definitely John and our colleagues need to work on to convince regulation that this is a crucial part of the whole story. And then a little bit more on the technical part, I would say first of all, one thing we need to work on, or we can leverage, I guess, in the future will be digitalization. I strongly believe because all the data is there almost. So just imagine, you saw it in the picture. We went to the scrapyard. What we brought in as experience as chemical companies, we know where our materials are used, usually, but there's a lot of uncertainty. But an OEM knows which part is made of which material. In principle, all the data is there. Of course, there are a lot of barriers how to share this, and sometimes we were struggling because the historic data was not there anymore, because we're talking about end-of-life vehicles, which are 20, 25 years old sometimes. That is an additional complexity. However, I strongly believe the data should be there. That will be a leverage, because that will determine how we're going to dismantle the cars in the future. That is one thing, that is the digitalization. And then there is a second thing, it's automatization as well. So we started with that. In the past, a lot of cars were dismantled manually. In China, this is still done to a certain extent. However, we strongly believe to take cost out of the systems, we need to more automate. So I personally don't believe that we will have this reverse dismantling lines, but there needs to be some dismantling, some automation at the end, as I said, to bring down the cost. And then there's a third one that I consider as very important is we need a certain centralization. So currently it's completely scattered, the market. So the scrapyards are all over the place, and at the end, to reach a certain level of volumes we require to reach economy of scale, you need to centralize somehow. So, and this then comes, just imagine something like a recycling hub or something like that. And when you bring together a lot of cars, then you can imagine, okay, this works much more efficient. You prevent then the logistics, at least to a certain extent. That definitely helps. And then the value behind this approach would be not necessarily in the first place look into the recycling of the materials, but rather start with more value our strategies. Start with reusing, remanufacturing of parts, take the parts out, resell them, and so on. And then only what we did, more or less, focus on what is left at the end. So that is what we believe. So let's call it a little bit of piggybacking strategy. To jump on the value creation, reselling parts, and then working on the recycling afterwards and extracting the materials. Yeah, so that is, I would say, these are the few things we consider. We are looking more into maybe expanding the group of companies, yes, and we might have to involve others who are even more specialized in these aspects we would need in the future.
Thanks, Matthias. And certainly these key areas around data sharing, around kind of collaboration, centralization, automation, these are going to be really, I think, important levers for us to move forward. Which brings me also to a question for you, Erik, around how can we, and what do you recommend in terms of really engaging across the value chain? And I'll just share also one of my experiences when we started this project. It was amazing to even just have the dismantlers sitting down at the table with the chemical companies who then need this plastic. I think it was probably one of the first times we had brought some of the ends of the value chain together. And this conversation and understanding, this type of plastic or this type of part is really valuable. And okay, how can we recover that? This is the kind of thing that I think is really needed if we want to actually churn these value chains into value circles. So Erik, maybe you can share a little bit about how can we then complete that and really engage also with maybe OEMs or other types of players along the value chain.
Yeah, excellent question. So first of all, it's a people's business. We are all working in different companies and also at different levels. So therefore, you have to motivate people. So this is the fascinating thing really about really here also people on stage, but also the entire team. There is really passion. So and therefore is trust, because contracts are for bad times. But we have to manage, and especially in Europe, to be at cost, but also for all companies in the value chain to make money. We cannot expect the scrapyard to say, you're doing something good, because this is also we have to think of. So at least in Middle Europe, around about more than 95% of automotive scrap go into energy recovery. So let's take 100%. And what we need to do really, it's 100 minus X. And if we are able in the first instance only to get out 10 or 20%, we won 20%. We have not lost 80%. But you have to motivate these people. And as you said, Amanda, it was very interesting. First of all, the crane, the excavator driver said, look here, what they are doing, what the hell. And then over the time, really, he was really fascinated. So we have to bring over the passion. On the one side, people have to make business. On the other side, they also need to understand that they are doing good and that everyone here in this value chain is important. It's an important contribution. And we are big chemical companies. Can we start to build up scrapyards, to have trucks? No, we cannot. So therefore, it's something everyone has a role to play. But we think as really material suppliers. So we can reach specifications, we can transform specification and pain points into recipes. So therefore, we are the ones who know the matter. But therefore, we are also the ones that need highest quality. Also in future, it won't be allowed to poison people in a car. So therefore, we have to ensure quality. So therefore, it's not to have 90% or less quality. We need 99.9. And therefore, to get there, we have to work together. We have to learn, we have to fail. And it's interesting because I had, like everyone, some insights and said, oh, this will work, this not. But then you think, oh, interesting, I didn't think about this and that. And what we also have to do, we have to build up really this network over the coming years. John said, so we will finalize till, let's say, maybe end of this year. This means 2032 regulation will come. But automotive, especially automotive, we need to start now. We have to have the network. We have to have hubs and mega hubs, because you cannot transport plastics over distance. It destroys the cost and everything. You have to build up structures. You have to build up really trustful collaborations, and you have to learn. And I think this is something where this is really a perfect team, and it's so much fun. It's so much passion here in the group. So you love to meet each other. Then also, but also with sorting companies like Steinert or with Ariont doing the shredding. So therefore, it's something where we will go step by step, but we see that already something is building up. And I think this is a very good foundation, and I'm sure that this is pilot is the beginning, not the end. because there are so many things to move. And as said in the beginning, we have, let's say, a competitive part where we have our own technology, but we have to work together. No one can do it alone, not the chemical industry, not here the big chemical companies, but also the entire, really from the scrap yards, converters, up to the automotive guys. We all have to work together and to make it happen, but it's also fun to do so.
Great, thanks. I think we have a little bit of time for questions, if we have any questions from the audience.